When we're working in inferential statistics, we have two hypotheses that we have to make, the null and the alternate hypothesis. And I need you for a minute to throw out everything you've ever learned about the scientific method, because that hypothesis has nothing to do with this hypothesis. So these are not what you think will happen. These are formulaic, either yes, it makes a difference, or no, it doesn't. So there's no creativity, there's no you trying to think of the outcome because that's what introduces bias. So when we write a hypothesis using statistics, and we're talking about the null and the alternate, it should be highly specific. So it should state your independent and your dependent variables and what's going to be the outcome. You can't be vague, you can't be ambiguous, you can't have an exploratory statement. All of that is for qualitative. It needs to be this curriculum will increase student achievement, specific. You need to use the appropriate terminology. So when we're in statistics, depending on your research question and your analysis, you're either predicting, associating, or comparing. And so you have to use the right keyword. There is no ability for you to change the format of these. Think about Mad Libs. You're playing Mad Libs. You cannot change the structure and format. The hypothesis must directly address your research question. So we're going to talk about research questions, and every analysis has a unique research question that it asks. And what you're going to notice is as we learn about each analysis, it's going to have a research question and then a hypothesis that's literally just rewording the question as a sentence. So the research question is very, very close to what your hypothesis is. And they can be directional and non-directional, so you don't have to say that there's a positive relationship or there's an increase. You just need to say there is a difference. So you're kind of being a little vague about that. In the null hypothesis, we always assume no change. So there's always this assumption that there's no relationship. It does not predict. It is not a statistically significant difference. Typically, we start to research something because we think it is making a difference. So, in that way, the null hypothesis is contrary to what we think. So, you get interested in researching something because you're like, oh, I see that. That looks like that's increasing student achievement. You're always for the null, it's not. And then the goal of the hypothesis test is really to play devil's advocate and to disprove the null. So every analysis you learn in this class, we are going to look at the null hypothesis and we're trying to bust it. We're trying to say that based on what we are finding, the null hypothesis is rejected. So by doing that, we're saying that if I'm rejecting there's no difference, I'm saying that there is a difference. So kind of the thing you have to wrap your mind around is that the entire purpose of inferential statistics is to disprove the null. That's exactly our goal. It's constantly looking at the null and trying to disprove it. So when we're writing that null hypothesis, this is just a repeat of the earlier slides. We want to be specific. We want to use the appropriate terms. We want to make it testable. So it's got to be clear there is no, and we have to be logical. So it has, again, to align with the research question, which all goes back to the analysis type. It's Mad Libs. If you're doing a regression, your research question is formatted in a certain way and your hypotheses are formulated in a certain way. There's not leeway to be creative there. So if I'm comparing the means, which would be a t-test or an ANOVA, my null would be there is no statistically significant difference in whatever my variable is between the groups that I'm comparing. So notice if I look at this here, I have what I'm measuring. So this is what I think is different. And then I have my groups. Students who get tutoring are in one group, students who do not are in another group. If I'm testing a correlation, the null hypothesis is going to say there is no statistically significant relationship between hours of studying and grade point average among college students. Proportions, there is no statistically significant difference. Getting the pattern? Testing predictions. So this would be my regression. There is no statistically significant prediction of weights based on height. And then finally, association. There is no association between smoker and the occurrence of lung cancer, which I saved this one for last because we absolutely know that there is an association in those two things. But again, the null hypothesis is not what you believe to be true or what is even true. It's always just the negative statement of it. Which then brings us to the alternate hypothesis, who is the red-headed stepchild of the hypothesis world. We state our alternate hypothesis, but remember, we don't touch that in inferential statistics because our entire goal is to disprove the null. So the alternate is going to have nothing to do with the analysis. You're either going to prove the null is true or you're going to prove the null is false. If it is false, that makes the alternate true. So it's this kind of really circular logic that happens, but the key is we're always focusing. So if you look at the alternate, the only thing that's different is there is a. It's the exact same statement. There is a statistically significant difference. There is a statistically significant prediction. There is a association. So when you're writing these hypotheses, it's literally just plain Mad Libs. If it's an alternate, there is a. If it's a null, there is not. So it's kind of a little bit easier to write these. And so I have included a job aid in the announcements. So go ahead and grab that job aid so that you are ready to write some hypotheses with us in class.